So this video is going to be a continuation of our discussion of repetition loops. So in the last video, we talked about the different categories of loops, whether it's a counter-controlled loop, a condition-controlled loop, a flag-controlled loop, or an end-of-file loop. Okay. And we also talked about the while loop, and the while loop can be used for any of those, okay, without any exceptions. But there are some cases, there are other structures that can be more efficient sometimes. And we're going to start with one of those, and it's the for loop. Okay, so a for loop is a counter-controlled loop only. So it's when you know how many times you want something to happen. Okay. Unlike a for loop in Python, this works differently. In Python, a for loop is an iterator. And this is not an iterator. This is just a counter. I mean, it is an iterator, but it doesn't iterate through a data structure like it does in Python. Okay. So the general form for this, we're going to have the for keyword. We're going to start with some initial statement where we're going to set our variables, a semicolon. We're going to have our loop conditions. This is kind of like what goes in the while loop on that, the part in the parentheses. Okay. And then you're going to have the update statement. Okay. So in many ways, you can think of a while loop as a compact, a for loop as a compact while loop. Okay. So that's what we're doing here. Okay. So for our initial statement here, for example, we could say something like, we often use I. We're going to set I equal to 0. Okay. So I have to have an int I up here. Okay. So now I'm in the loop. I'm starting off with I being 0. Okay. So we would then have, and the book talks about this, and you know my feelings, that if there's only one line, you don't have to have brackets, but if there's more than one line, you do. But I think there always have to be brackets, or it just is difficult to deal with. Okay. So anyway, that's our initial conditions. It could be whatever variable you want. The variable has to exist before you get to this point. Okay. The next, after the initial condition is the initial statement is the loop condition. Okay. So this is going to be what, what has to be true for the loop to go one more time. Okay. So in this case, it could be something like I is less than 10. Okay. If I is less than 10, we're going to keep going. So the initial condition is I is 0. Okay. Which is fine. So now we're going to go I is less than 10. So I is less than 10 when we start. So we're good. Okay. The update statement is what keeps it from going into an infinite loop. And it's that you have an I plus plus. So in this case, we're going to go 0, 1, 2, 3, all the way up to, but not including 10. So we're going to go up to 9. Okay. So that's it for the structure. That's all we have to worry about. Then I can just see out I in here. That's all we have to do. That should be sufficient. Okay, let's compile this and see what it's going to do for us. I'm doing the lazy person's way by not doing the dash O. Okay, it doesn't like something. Oh, it's an N, not an indel. Indels could be problems today, which is very strange. Okay. So instead of all that, let's do an A dot out this way. Okay. And you see it does, it goes from 0 through 9. Okay. And the way the loop works, this I is going to take the value 0, then I has 1, so forth. Do whatever you want. Okay. So again, this would be the equivalent. This looks just like the loop. I equals 0. Then we can do a while I is less than 10. See out I end line. I plus plus plus. There you go. Does the same thing. In fact, if I were to see out new lines, some other spaces, and a new line right here, and we run this. So I've done something else awful. We should see the exact same thing, 0 through 9, 0 through 9. Okay. So in the last video, I had said that you can always use a while loop for everything. So we see this, but instead we have 1, 2, 3, 4 lines instead of 1, 2, 3, 4, 5, 6 lines. So yeah, it's a little cleaner. Um, and it can be easier to read because everything's right there together and you're not going to forget any of it. Okay. So all of these are optional, but it turns out to be very difficult if we don't have them there. Okay. But you have to have the colon or the semicolon there no matter what. Okay. So if, for example, let me get rid of all this stuff. If I were to set I equal to 5 right here and not reset I to 0, but just leave that there. I mean, it should work, but see, it just starts from there, which is not normally how we do things. Okay, it's a bad idea. And even worse, if we set it to where the initial condition is false and run it, still no error. It's just not going to do anything. It never makes it into the loop. Okay. So it makes the most sense to put our initialization in here as far as the values go. Okay. If there is no loop condition there, not going to give an error, it's going to go forever. It's going to be an infinite loop. Okay. And then if there's no update here, you could do it yourself inside of the code, but that you would have to make sure that you do that. Okay. So that's the basic idea with that. Okay. And when it comes to this can be whatever you want. We could say I is equal to I plus 2, and that's perfectly okay. 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 Now we go 0, 2, 4, 6, 8. Okay. Um, if we were so if we're going to do 1 to 10, people often do this. Okay, 1 to 10, right? Life's good. Run it. I suspect life is not good, but let's check it out. Okay, it's not. Okay, it that's not going to show me what I need to show me. Let me go back to here. These can also go negative if you would like. Okay, but you have to make sure the initial conditions. This is what I'm trying to do. Yeah, this still just goes to 9, and you thought it was going to go to 10. That's what's known as an off by 1 error, really common. So what I need to do, 2 things. I could move this to 11, which feels kind of icky to me. So I'm going to say less than or equal to 10. Okay. And before I do anything with the loop, with a for loop, I'm going to make sure that it's giving me what I want. But that's not what I wanted. That's what I wanted. Okay. So I now have 1 to 10. That's what I wanted. That's what I got. Okay. So again, this could be negative. If so, it would have to be something like, if I want to count down backwards, start with 10. And as long as I is greater than or equal to 1, let's say, and then do I minus minus. Okay. It's not what I want to do. That's what I want to do. Okay. And now you see we're going from 10 down to 1. Okay. And anything's possible there. Any kind of math that you want to do is perfectly okay. Okay. So that's the basic idea with this. One thing that the book mentions that we've run into this before, if you put a semicolon here, and a lot of people are, it seems like a lot of you are doing this on your if statements. You would like that to give an error message, but it's not going to do it. Okay, what it's going to do, I'll show you what it's going to do. It's one of those cases where you're left on your own in C++ a lot. It just doesn't do anything. Okay, it gives us a 0. This loop never happens, basically, when you put the semicolon there. Same way with the if never happens. So yeah, you don't want to do that. Okay. So the last kind of loop we're going to cover is a do while loop. Okay. I will say that I don't think I have ever used a do while loop in my entire programming career. Um, they're kind of special purpose. But I guess to say that I haven't used it, I'm sure there are times, I know there are times when a do while would have made more sense. I just find the syntax weird, and there's always a way to work around it to just do a while loop. Okay. So not saying that it's better to not do whiles. Do whiles have their place. It's just not something particularly that I tend to do a lot of. Okay. But a do while works like a while loop, except it tests at the end. Okay. So otherwise, just like a while loop. So let's take a look at an example. And again, you'll see why I think it's a little bit weird. So we're going to initialize up here our I being equal to 0. We start this with the do that then gets some brackets. We're going to see out I, and I'm going to put a space there so we're not doing end else. Okay. We're going to say I is equal to I plus 5. Okay. That's all we're going to do. We're going to get out of the do part. Now we have a while the next line down. Okay. And in this case, while I is less than or equal to 20. Semicolon. That's weird. It's all weird to me. It's weird the while is not part of the brackets. It's weird there's a semicolon at the end of that line. But there is. Okay, so okay. That's how they work. So let's make sure I've not done anything wrong there. Yep, we get 0, 5, 10, 15, 20, as we would expect. So they're a little bit weird. Okay. But they do work. Okay. So the next things we're going to talk about are some commands we can use to alter the way that our loop's going to function. So we've used break already with the switch statement, right? So if you're in a switch, you have your cases. It evaluates whatever you're doing your switch on, and it goes to the case that matches that. When you execute the statements in that case, you then want it to stop and not do the rest of the lines in all the other cases. So you hit a break. Break gets you out of the switch. Okay. It works the same way in any other kind of loop. Okay. That was a control structure in a loop. So in a for loop, in a do while, in a while loop, it will totally break you out of the loop. Okay. So after you hit a break, it's going to continue on with the line after the um the loop structure itself. Okay. So let's do another example here. This one's from the book. This is going to be a program that's going to sum up some numbers. Okay. And until or unless, I guess, someone enters a negative number. Okay. So go by int sum is equal to 0 up here. I'm going to see out, enter some numbers separated by a space. Okay, so I'm basically here building the CN buffer. Okay, I'm gonna have another int up here for a number. Okay, so I'm gonna CN my first number. That's gonna be the first number that I entered. Okay, I'm now gonna do this while CIN. Okay, while CIN. And what this is doing for us, this is saying as long as there is something in that queue. So if I enter 5 numbers, it's going to keep going through all 5 of those numbers. Okay, so that's the basic idea behind that. Okay. And now I'm next going to check to see if any of the numbers that I've input are less than 0. Okay. So I'm going to say if num is less than 0. Okay. I'm now going to see out that there was a negative number in data. Negative number in data. Okay. Indel. I'm going to type in break. Okay. What the break's going to do, it's going to take me out of the while loop. Okay. But I'm still in the while loop now. And if I say sum is equal to sum plus num. Okay. And then I'm going to get my next number. Okay. That ends everything. Okay. So this is where the break will go. Okay. So again, if I enter the numbers 1, 2, 3, okay. So num's equal to 1. Okay. It comes here. There's still something there. Num is not less than 0. So it's going to skip this. It's going to sum it up like normally. Okay. But let's say I enter 1, -1, 5. Okay. The 1's going to come through like normal. Add to sum. Sum's equal to 1. It's going to come back up to here. Now it's going to say, oh, it's a -1. So it's going to hit this line and say, oh, we're going to print out it's a negative number. Break is going to move us down to here. She'll ignore the rest of it. Okay. And it doesn't do anything with that. Okay. Let's take a look at this. See if I've got it compiled correctly. Okay. So if I do 1, 2, 3, that's not happy with something. That's really weird. See what I'm doing. Wow, send that yeah, it's like it's not getting there. This program's from the book. That's a weird program, but I didn't do it in advance. Let's see anything that we're doing wrong here. I don't know if I'm ever making it into here. So let's try this. See out. Okay. So it's making it there 3 times, which is fine, but it's not stopping. Okay, so that's a different issue. Okay, so why is it never stopping when it gets to there? Looks like the issue may be, okay, so it's doing that okay. It looks like it's waiting for numbers it's not getting, but it does it 3 times. Really strange because it's not making it to here. I'm guessing. We try that. Yeah, it's never making it out of the loop. Okay. Let's see if, for example, that hitting a negative number, so 2, 3, -1 makes a difference. Yeah, that did make a difference. Okay, that worked, and then it took us out of the program. So it's something, if it's all okay, clearly doing something funny in here, but I'm not sure right off what it is. I guess for our purposes, it doesn't matter. It's showing what the continue does. Okay, that the continue is just going to take us totally out of the loop. Okay. I guess a different example could be if we just enter numbers individually. Let's try that. Okay. So I'm just going to say enter a number. Give a better idea of what we're doing. It'll work better for our next example anyway. Enter a number, see a num is okay. Okay, we're still doing all that stuff, still have our break. And then here we're going to have to ask again. See out. Number. See and no. Okay. Then we can say here, we'll change our while to say while. It's not equal. Let's say that zeros are get out of the loop thing. Okay. Let's try this. Okay, so run this one. If I do a 1, if I do a 2, if I do a 3, we're good. If I do a 0, we're out. Okay. And the same way, if I do a 1, I do a 2, I do a -3, it's immediately going to dump you out at that point. Okay. So that's the point of what the break does for you. Okay. So the other word that goes along with this is a continue. The continue only works with looping structures. Okay. What the continue is going to do is it's going to go on to the next iteration. Okay. So basically, if we hit this continue, it's going to skip this. It's not going to add it to um, to the sum at all. Okay. And it's going to go back around. So this is not going to work for this. We're going to have to move this up. Okay. So we have to move this up to here to show what that's going to do. Okay. And then up here, I can just set num to be anything. Doesn't matter. Whatever we set it to here is going to go away. Right. As soon as we get in there. Okay. So inside of the loop, not equal to 0. It's not. It's equal to 1. Okay. We're going to ask to enter a number, get that number. So if the number is less than 0, so if it's negative, we're just going to say negative number in the data, continue. It's going to skip the sum, take us all the way back out to ask to enter another number. Okay. So in fact, that makes more sense to print out the sum. Okay. And this, again, if you wonder what does that end, put it in again, you see that ends the while. Okay, and it's the C out is the line that you see it's at the same level as the while. This is where we're going to end up with when the loop's over, but we're not doing a break, we're doing a continue. Okay, so a break is used when you're processing the loop and whatever has happened means you're done. Okay, you don't want to loop anymore. A continue means that you're done with this time around. Okay, but you want to go around again, basically. Okay, so let's run this one and see what it does. Okay, enter a number, enter 2, enter 3, enter a -1. Just doesn't do anything with it. So we've got 5 so far. Enter a 5, enter a 0 break. Our number's 10. Okay, so the continue just keeps on moving. Okay, so if you had like a list of numbers you wanted to go through that you're pulling from a file or whatever you're pulling it from, okay, and you only want to add up the even ones, same kind of a deal. Is a number, if the number's even, continue, go to the next number. This allows you to skip it for this time around. Okay. So the last thing we're going to talk about is in some ways the most daunting, I think, for folks. And this is the idea of nested loops, nested repetition loops. Okay. And what you almost always see are going to be nested for loops. Okay. We have a for loop being equal to 1. I is less than or equal to 5. I plus. Okay. And here's what I would do. I would start by making sure this works the way you want. Okay. That's my whole loop. Okay. So I'm going to run that. I want this to be 1, 2, 3, 4, 5. See, I'm already unhappy. I didn't declare an I. Wish I would quit doing that. Okay. 1, 2, 3, 4, 5. We're good. That's my I values. Okay. Now inside of this loop, I'm going to do another loop on J. I'm going to say for J equals 1, J less than or equal to 10 j plus plus. Okay, so it's going to go from 1 to 10 inclusive. Okay, I'm going to see out, just so we see what's happening here, an I, a tab character, and a J, then a new line. Okay. So the question is what order is this going to go to? So are we going to see the I's changing first? Is going to be I1, I's 1, J's 1, I's 2, J's 1 still, or what? How's it going to work? Okay. Well, let's print, then we'll talk about it. Until I do something dumb like not declare my J. Okay. So we see the I stays 1 for the entire loop that J goes through. Okay. So J goes from 1 to 10, and then we go to 2, J goes from 1 to 10. Okay. I think this makes sense if we look at this carefully. So what this is saying is we're getting here. We're getting inside with I being 1. Okay. The control is going to flow down to here where J is equal to 1. So now we're at 1, 1. So when we get to this line, okay, I is 1, J is 1. We print out 1, 1. We hit here. We go back to here. J is 2. I is still 1. Print out 1, 2. Come back 1, 3. Okay. Only when this hits 11 do we skip to there, go back to here, and get I being 2, and start back over at 1. Okay. And keep going in that way. Okay. So that's how that works. Okay. So I like to think about it in some ways. If you have a bunch of filing cabinets, let's say you have 5 filing cabinets, each of those has 10 drawers. Okay. You start by going to the first filing cabinet. That's the I, and you're in drawer 1. Okay. Where you go normally is to drawer 2, still in the same one. Okay. So that's kind of how that works. Okay. Can you make it loop the other way if you wanted to? You could, but there's gonna be a lot more to do there. Okay. But this is the general way that we want to do things. Okay. So we're going to go the outer one and the whole inner one executes. Okay. So this part of the code, okay, all this loop as a whole is going to execute 5 times. Okay. This outer loop does 5 times. So, okay. For each of those 5 times, this line is going to execute 10 times for each of those 5 times, or 50 total lines. Okay. So we're going to get 50 lines printed out on the screen. Okay. So if that's unclear, think about it. You can always ask questions. Okay. And again, with loops, the big things that we're worried about, or the biggest thing we're worried about, is the off by 1 error, where you end up getting 1 less or more than often than not 1 too many. So be careful when your terminal values using the less than or less than or equal to or greater than equal to, whichever one you need. Okay. Well, that's it for loops. So next stop will be functions.